So we'll be solving for the equilibrium concentrations for the solubility product. So our equation, as what is given, the KSP equals 2.0 times 10 to the negative 29, and this is our equation, so Ca3, PO4, 2, solid. So we have to break this down into ions. So this becomes 3Ca because this becomes the coefficient, and the charge is plus 2 because this is 3, so and this is 4, PO4, which is phosphate, which has a minus 3 charge, so minus 3 times 2 is negative 6, and to have positive 6 on the Ca, it would have to have a charge of plus 2, so 2 times 3 is 6, so they cancel out. So this becomes plus 2 charge plus, there's 2, so that becomes the coefficient, 2 PO4 minus 3 charge. So now we can write out our KSP, which equals, and by the way, these are aqueous, and we can use our KSP to solve. So it becomes concentration of Ca plus 2 to the power of 3 times PO4 minus 3 charge to the power of 2. And that is our equation. And it's not over this because this is a solid. And solubility product only works with gases and aqueous. So that's what we do. And then our initial, we have to, this is a solid, so there's no concentration. This is given as 0 concentration, and this is given as 0 molar. Then we can do our change, which is our C. So we can plug in to find our Q, and we can plug it just into that. So it becomes 0 pretty much times 0. What does that equal? Obviously 0, and 0 is less than our KSP. So that means we have to be going to the product side, so there can be more and it'll balance out. So our C is plus coefficient 3x plus what? 2 plus 2x, and this just becomes dash because it's solid, we don't worry about it. Then for our equilibrium, again, dash. Here it's 3x because it just brings down, you just plus them, but 0 plus 2 is just 2x. Then what we can do is we can plug this back into our KSP equation. So it becomes 3x quantity, and what is it? Cubed, times 2x quantity, what is it? Squared. And that is equal to our KSP, which is 2.0 times 10 to the negative 29. Then what do? We go to our numeric solver. We go to math, and we go up, numeric solver, and I plugged it in 2.0 times 10 to the negative 29, and 3x quantity cubed times 2x squared. So once you plug that in, press enter, you make the 0, you go up, and you go to alpha solve. What do you get? 7.1 times 10 to the negative 7. So our x is equal to 7.1 times 10 to the negative 7. That is what our x is equal to. Now, to find the equilibrium concentration of Ca plus 2, equilibrium, and PO4 minus 3, equilibrium, that we just plug in 3 times x, which is 7.1 times 10 to the negative 7, and our coefficient, we just plug in that 2 times x, 7.1 times 10 to the negative 7. And we can do these, we can plug them 3 times 7.1 times 10 to the negative 7. What do we get? We get 2.10 times 10 to the negative 6. And then we can do 2 times 7.1 times 10 to the negative 7. And for this one, we get 1.4 times 10 to the negative 6. And these are molar. And that is how you find the equilibrium concentration. And there's your answer.